Well, ladies and gentlemen, here we are again at the Roger Ranch. We have Doctor Who in the background, and we're going to talk a little bit about some decision analysis here tonight. So let's get started, and maybe we get started. Yes, there we go. So, we'll take a look. What are the components of decision making? Can we do it without probabilities? Can we do it with probabilities? And then what happens if we have additional and even perfect information? We will also take a look at a concept called utility. So in decision analysis, we look at things called a state of nature, an actual event that may occur. And we can often put these in a payoff table. Again, almost the entire world could be reduced to a 2x2 matrix that looks something like this payoff table. Gives us the states of nature and the decisions that we can make. The first decision we're going to look at here is one with probabilities. And depending on different economic conditions, should we buy an apartment building, an office building, or a warehouse? So let's take a look here. And the apartment building, under good conditions, costs $50,000. Well, we can make $50,000. The office building, we can make $100,000. And the warehouse, we can make $30,000. However, under poor economic conditions, we could only make $30,000 with the apartment. The office building will lose us $40,000, and the warehouse will make us $10,000. So we have these different criteria. One is a maxi-max, one is a maxi-min, one is the mini-max, one is the mini-max regret, and then there's the Hurwitz and the equal likelihood. We'll take a look at each one of these. So in the maxi-max, we want the best. We want the bonanza. So, we want the result with the maximum payoff of all, and we're very optimistic that this is going to occur. So in this particular case, the maxi-max is the office building under good economic conditions, which will net us $100,000. Now in the maxi-min, the decision maker looks at this decision and wants the maximum of the minimum payoffs. So we look here under poor economic conditions. If it is poor economic conditions, what's the maximum we can do? Well, take a look over there. Which one is the best? The best one is $30,000 we can make if we do the apartment building. Now, regret is the opposite of these tables, of this payoff table. It's the difference between the payoff and the best decision and all the other decision payoffs. And usually the decision maker wants to avoid the regret. So again, where did the $50,000 come from? Well, take a look. 100,000 minus 50,000 gives me 50,000. 100,000 minus 100,000 gives me 0. And 100,000 minus the 30,000 gives me the 70,000. Here, on the poor economic conditions, we take the best one. 30,000 minus 30,000 gives me 0. 30,000 minus 40,000 gives me 70,000, which is here. And 30,000 minus 10,000 gives me 20,000. So the minimum regret here is 50,000. We have to look across both columns in this case because good economic conditions and I can make 50. The most I can lose is 50. In the office building, the most I can lose here is 70 if I have poor economic conditions, and I can lose 70,000 in the warehouse. Remember, the regret is the opposite. It's a difference between the payoff. So we have to think in an opposite direction here. This is not how much we're going to make, but how much we're going to lose, what we would regret, what we would lose. And so the minimum regret value here is 50,000 because that's the smallest number here. 50,000 and 0, 0 and 70,000, 70,000 and 20,000, 50,000 is less than 70,000 here, less than the 70,000 there. Now the Hurwitz criteria is a compromise, and what it does, it gives this coefficient of optimism, an alpha, and that's what the decision maker feels is the possibility of good conditions or bad conditions, etc. It multiplies the best payoff by alpha and the worst payoff by 1 minus alpha. Remember, they have to add up to 1. So each one of these decisions gives the best result. So if we feel that there is a 40% chance that there's going to be good conditions, a 60% chance there's going to be bad, the apartment would be the 50,000 times 0.4 plus the 30,000 times 0.6 gives us 38,000. The office building gives us 16,000 and the warehouse gives us 18,000. The Hurwitz would say that we should buy the apartment building because we can make 38,000. Remember, this is not a regret table. This is, straight up states of nature. Okay, so now the Laplace is the equal likelihood, 50-50 chance, and so we take 50,000 times 0.5, 30,000 times 0.5. What do we come up with? Well, they're going to tell us that we should buy the apartment building here because it's going to get us $40,000. So the dominant decision that it gives us a better payoff than the other ones is the ones that we're going to pick. And this appropriate criterion is dependent upon the risk that we're going to take. So the maxi-max is going to tell us to take the office building. But the maxi-min, the mini-max regret, the Hurwitz, and the equal likelihood all tell us that we should pick the apartment building. Again, we can do this in Excel, and we can do this in QM. I wouldn't suggest using QM. I would suggest using Excel straight up. And again, if we do this, here again are our apartment building, our office building, a warehouse, and this gives us our maximum regret, which is again 50,000, and this is a regret table. And so here we're going to buy the apartment building in this particular case. And again, if we do it with Excel, we can fill in the cells and come up with the same thing. Now again, an expected value is computed by multiplying each decision outcome in each state of nature by the probability of its occurrence. So here again, if we have good economic conditions and take 50,000 times 0.6 and 30,000 times 0.4, and then the expected value of the office building is 100,000 times 0.6 minus 40,000 times 0.4, and the warehouse is 0.6 times 30,000 plus 10,000 times 0.4. Here we're going to find out that the expected value for the office building is going to be the best one. It's going to give us 44,000. Under this expected value, this is the one that we would pick, which is the office building. Now, again, an opportunity loss is the regret table. It's the opposite of that. We're going to do the same thing that we did before. So 100,000 minus 50,000 gives us 50,000. 100,000 minus 100,000 gives us 0. 100,000 minus 30,000 gives us 70,000. So if we take these now and we this expected opportunity loss, we're going to come up with expected opportunity loss here of 50,000 times 0.6. It's 30,000, 28,000, and 50,000. Well, again, the office is the best one because this gives us the lowest expected opportunity loss. Here again, we can go through this with QM for Windows, and it's going to give us, again, this the expected value is 42,000, and we can do this in Excel. And so the other thing that we come up with now is the expected value if we had perfect information. What would you pay for additional information to make the right choice? And the expected value with perfect information is going to be the perfect information minus the without perfect information. So this is the expected opportunity loss for the best decisions. So here again, we had 50,000, 100,000, 30,000, 30 minus 40 and 10. We've seen these all before. Under good economic conditions, 60% chance it's going to occur. Poor economic conditions, 40%. So with perfect information, we're going to take the 100,000, the best one, times 0.6, and the best one we have over here, 30,000 times 0.4. And what are we going to come up with? 44,000. Now remember before, our expected value with perfect information is going to be 44,000 was the best that we came up with before. Remember that 44,000? Have to go back here and find, there's our 44,000 right here, right? We said, see, that was the best one that we could come up with. So, but now if we had perfect information, we could do even better. And so what we end up with is this idea of the 44,000 was the best we could do before. Here we came up with 72,000, and so with perfect information we could make 28,000 extra dollars here. We can do that much better. So again, this is decision making with probabilities. And again, we can do decision trees, and these decision trees are branching, if you will. They have decision nodes, which are squares. They have probability nodes, which are circles, and they have decision alternatives, which are branches. And again, these under good economic conditions and poor economic conditions. And here is a decision-making probability decision trees with good opportunities. Let's stop there and